talking about two presentations. Both are in the realm of mixture of experts. These are models that allow for some sort of predetermined inference. So when input data comes in and the model has to do inference on that data, instead of using the whole model and all the weights of the model to come up with the most probable outcome, let's say in the case of a transformer, to predict the next token, you can delegate that task to what's called an expert, which is part of the network that is specifically trained to execute certain tasks. So in the context of a language model, this can be maybe a part of the model that is particularly good at grammar versus part of the model that's particularly good at poetry versus maybe particularly good at Python. Like that's a whole other area of research of how granular the expertise could be, should be, and what the upside downside is for for having more granularity or less. In fact, it's not even clear whether the mixture of experts as a whole even makes sense. But as a concept, it's a good idea. So we want to talk about it. There was a person from Mistral, the company behind Claude and those sort of things. I believe it's them. I'm actually not even sure. So it's one of those companies that competes with OpenAI on the transformer side of things. So they came to Stanford. They came to Stanford and gave a presentation about their model. And there is also another presentation I want to talk about in context. It's about a year ago, same class, the transformer class at Stanford. These were two guys from Google. They talked about what they call mixture of experts versus switch transformer. So the concept is always the same here, which is you have a gating function, a learned gating function that allocates input data to very specific parts of the network. The reason I'm interested in this is because, well, one is, of course, it's an interesting area being discussed in the industry, but also Musk spoke about particular advancements in inference. And also Andrew Ng's talking about this recently. So I want to kind of start a little bit of a side project here and do some more research on what it means to do inference and how inference can be more optimized and how particularly compute, software, and algorithmic solutions can lead to better, more efficient, more optimal inference. This is not even a podcast. It's April 26, 2024. This is Cryptelco. Since the last update, we're up about 6%. The market is up 1% for the year. We're down 19.2%. The market's up 7%. We're underperforming by 26.2%. We continue the rally in Tesla after the earnings call. We also had some good results from Google and Microsoft, which is buoying the market. I think overall where we stand here is we still have a lot of euphoria around AI. The market's still investing massively into companies that are going to take advantage of Gen AI and build the next generation of AI companies. This is like the internet in the 90s. It's even stronger because it's changing everything. It's changing the compute stack. It's changing the way people process data, and then on the front end, it's changing the way people do business, the way people monetize. It's interesting. It's exciting. It makes me work. The way I judge fields in general or areas I want to invest in is like I judge artists. They make me work. They make me think and work. The best is work. If they make me think, that's a good thing. If they make me work, that's great. And sometimes I'm not interested. Blockchain, for example, it might be an interesting area, but I'm just not interested. Every time I go to a crypto conference, it's depressing to me. People spend their time thinking about these types of concepts. So I'm not interested. This I'm very interested in particular. What we're interested in is real-world AI, which is embodied decision-making agents, and that's why we have large positions in Tesla and NVIDIA. Now let's talk about those two presentations. Let's start with Mixtral or Mixture. What's the name? So Mistral has this mixture of expert model, which just got released. And what generally what happens is, let's take a step back. Okay, when we train a transformer, we run a transformer on, let's say, internet scale data, and the transformer learns several tasks. We discussed this also when the OpenAI guys came. This is C25, by the way, the class C25 at Stanford, highly recommended. I believe it's open for the public if you zoom in, so it's really highly recommended. What they anyway, so they had OpenAI guys presenting recently, and the one thing that they spoke about is this sort of linear task evolution of the model. So it's like you train the model and it learns to do, let's say, you know, spelling, and then it learns how to write poetry, and then it learns how to fill in words, and then it learns this and that. So there's this sort of task-wise understanding that the model starts gaining with each you know, epoch of training. What I mean with that is, of course, it's not linear. It's not clear how many epochs you need to learn you know, one more task. But the more you train, the better the model becomes at tasks, and these tasks kind of accumulate almost cumulatively. That's the interesting thing. And this is actually congruent with the mixture of experts model, which says a similar thing. The mixture of experts model just says, look, we have different expertise in the model. So we've trained this gigantic model with, let's say, 5 trillion parameters, or, you know, who knows tomorrow where it's going to be. Lots and lots and lots of parameters. Okay? In other words, lots and lots of weights. And those weights, they represent as a whole function approximation to solve tasks. And now, one big model is, the beauty about it, the generalization of it is, of course, you can do anything with it. You can ask it all kinds of things, which is where we are today with GPT and Claude. And the idea of mixture of experts is, well, why don't we train the whole thing, but then in inference time, not use the whole thing all the time? And there is another big takeaway from the OpenAI presentation, which is that actually parameters, as important as they are, compute is much more important. So what you want to do is you want to run more iterations with a smaller set of parameters. So if you had to choose, and there's this concept of Pareto optimality, which kind of means in this particular area, Pareto optimality comes from economics, and it's a frontier, it's a line where if you change one parameter, if you change one thing, you are gonna have to take away from somewhere else, right? So this is, you know, even in John Rawls' definition of fairness, it's the same concept. Sorry for the tangent, but John Rawls, who says a society's unfair if you can improve one bit of it. So let's say the lowest level of society can be improved without hurting anybody else. That is the definition of unfairness. So in a sense, we should do that, right? We should invest in a public high school in our village. It's not hurting anybody, but it's making one child better off without hurting anybody else on aggregate. That is worth doing. So again, Pareto optimality means that once we're there, so once you're in a Pareto optimal situation, you can't improve anymore without hurting something else. That's what Pareto optimality means. Now it's more of a, I would say, conceptual thing than anything else. I don't think that, you know, you can walk through life and then there's something on your screen popping up and saying, "Well, you just reached Pareto optimality. Sorry." Like, it's not like that, right? You have to kind of gauge. It's like a lot of things, particularly in economics, like invariance, indifference, isomorphism, things like that. They're all conceptual concepts. Like, there's no such thing as indifference in real life. You can't be indifferent about something. It's just impossible, because you're gonna have to make a decision. And if you don't have to make a decision, then indifference also is kind of, you know, makes no sense. So it's almost a Gödelian, you know, self-reference. So sorry for the tangent, back to the mixture of experts. So we are talking now about the optimization of a model. So we have all these parameters that have been trained. And now the question is, when we do inference, should we literally, should we check the model for all its weights to see where in the model this particular input data is most useful? So if my query at GPT is, can you write me a Python code to solve to solve a particular looping problem in my app? Like, that's a very specific task, and the model doesn't necessarily have to check what it's learned about Shakespeare and what it's learned about U.S. history and whether French Polynesia was being conquered by the French or the Spanish first. It's not relevant. So why go and check those weights? Why go and check those that kind of relative attention matrix that connects words with French Polynesia? Like, it's completely irrelevant, right? However, there's a part of the model that has been trained on GitHub where all these kinds of things matter a lot. So the gating function, now that's a learned function approximator itself, figures that out. Like the gating function, which is literally like a router, understands that this particular input, that the words, this connection of tokens, let's assume a token is a word. So this collection of words needs to be inferred in this part of the model, not in the whole model. So that's what Mixture of Experts really means in a nutshell. It's very similar to neuromorphic compute in the sense that you have decision making before processing. So and that's kind of how humans probably operate. That's at least what we think is happening in our brains, right? I mean, if you ski down a very steep slope, you're not going to think about your Python model that you just worked on the day before. And when you work on your model for whatever ComSci project you're doing at Stanford, you're not gonna at the same time think about the next big steep slope you're gonna climb. Like, you're segmenting your thinking, right? Now, we're not sure that that's really happening, okay? This is conjecture. Neuroscience has tools to prove that, but I would take that with a grain of salt, simply because neuroscience is not there yet in terms of really telling us what's going on in the brain. However, again, as a concept, it's worth thinking about it, and this is where we're going to leave it here, because we could discuss this now ad nauseum, whether, let's say, okay, let's discuss a few pros and cons here. Like, what's the pro of Mixture of Experts? Of course, I can dissect the model, I can do faster inference, I need less memory, I can load maybe the weights of a model on a smaller GPU. I can have 8 experts on 8 different GPUs, and then my gating function just moves the input on the one GPU where the expert is most useful at. I think the way they do it is they usually would use 2 and then use a weighted average, because they also want to give the gating function some room of error, or room of, sometimes there's just no such thing as binary a 0 or 1 when it comes to, if I ask a question about history and the expert is also maybe required to do a good narrative, then maybe those are 2 different skills that are in different expert section of the model. So I might do a weighted average. So these are all, like, I think, anthropomorphic approaches, because that's how we think. That's how we think we think. Whether that's really how we think, again, that's a completely different conversation. So the reason I'm interested in this whole discussion is, like I said in the prelude, I'm starting a new project which is really understanding inference, right? We've been talking about training a lot in AI, and everybody who talks about AI these days, at least in the mainstream, is talking about training models, size, billions of parameters, all of that stuff. I think we want to switch the conversation now to inference, because Elon Musk spoke about it. He actually even made a reference towards a potential business model that could arise within Tesla, and that is to use the FSD inference chip as a as a sort of AWS style offering, sort of inference in the cloud, inference on demand, something like that. What makes inference challenging? What makes inference better than other inference? Those are the questions we want to discuss, and I think Mixture of Experts is certainly part of that conversation. So the way you can have more efficient inference is, again, by gating the input towards certain subtasks, sub areas of the model. What's the downside of this? Well, I guess one of the downsides, it's kind of like, think about a human. If you dissected a human, if you took away certain parts of her brain and then made her do tasks, my guess is she wouldn't be able to do it. In other words, there's more connections than we think. There's more to this than we know and think. Because we don't quite know how knowledge is stored, how connections are stored. I mean, that's what part of the transformer architecture is, to use self-attention and cross-attention for exactly that reason, to have some spatial idea of, okay, this knowledge is very often related to that knowledge, so there's a relationship, and when we do inference, we better combine those two. But that's part of the gating function. Like I said, if my task is to do poetry, then maybe my ability to write Python code is really not so important. But then again, maybe being concise and having the ability to write something in a very short, concise manner, maybe that's part of poetry and part of programming. So maybe we shouldn't dissect those. So that's, I think that's where the research is. This is literally what academic research is supposed to do. It's supposed to think about these things and find clever ways to do experiments and test conjectures and come up with knowledge about, okay, well, this type of mixture of experts works, this type doesn't. We shouldn't even do it. We've just proven that we can potentially just get away with sparsity, which is another concept that was discussed in the other Stanford presentation that I mentioned in the prelude. The two Google people, what they were discussing is kind of similar, but it's different. So think about it this way. Think about a model that is trained and it has a lot of parameters. But dependent on the input, lots of the parameters get set to 0. So this is subtle, but it's different, right? What you're doing here is you're kind of switching off parts of the model that are not necessary. And you do that by having, again, a trained gating model that says, look, this type of token combination really doesn't need these parts of the model. These parts of the model will have very, very low probability success or very low scores in terms of delivering any kind of inference. So let's set them to 0. We don't even need them. The upside here is low communication costs, low transaction costs, but you still have to store the whole thing. You just don't use the whole thing. So there's a bit of that. I think that's part of why the research community is so interested in this. These are just people are tinkering. This is engineering at its best, right? You're just trying out. You see, well, okay, this works, this doesn't work. So to summarize, Mixture of Experts is an interesting concept. I would say at this point it's more of a concept than anything else. The fundamental idea is that we can train a model with massive amounts of weights, trillions, but we don't have to use all of those weights at the same time during inference time. Is there a smart way? Is there an intelligent way to gate the input data towards parts of the model that are useful, either by having separate predefined parts called experts, or by turning off, or that's what's called switch transformer, by turning off weights that are most likely not going to be useful for the type of inference. And overall, again, we're working on an inference, or on the concept of inference. I think this in itself is worth doing some more research, particularly in our situation, as large investors in Tesla and Nvidia, I think both of these companies will actually make a lot more efforts going forward on the inference side, which is becoming more and more important with AI getting closer to the customer. Thank you.